Okay, welcome again. I'm recording now. I wasn't recording before. Basically, what I was saying was that this week is going to be more like how the rest of the weeks are going to go. It's going to be maybe 15, 20 minutes on what the assignments are, what the code is, what's being taught. And then the rest of the time we'll be designing databases or going over someone else's designs, helping people troubleshoot and figure out their designs. Tonight, I have a student who wants to design database based on like races and 5K. So we're gonna kind of play with that and see how that looks. And if any of you all have an idea that you're getting stuck on, shoot me an email, bring it up in the actual class and the not class, but this get together, and we can go through it and I'll show you. We'll talk about it and open the field up to suggestions to the entire class. And it really will help you guys to get the idea of how databases grow, how they move, how the tables and everything logically fits together. Okay, sound like a plan? Excellent. So this week is all about outer joins. If you remember the Venn diagrams from last week, let me redraw them here. Let me change this to the whiteboard share. Okay, so remember we had this circle here and this circle here. And when we talk about inner joins was this area in here where the tables intersected. That's the word from this week's lesson, intersect. This is where the inner joins live. It shows you where the two tables have commonality. Outer joins show you where, let me change the color of this. Outer joins show you where the table in the focus has commonality with just this little part of the other table, okay? So this, if I were to do this would be a left outer join because this this part of the is on the left and this is on the right. I'm gonna show you in code what that means. But when you think about how left and right joins work, if you see the tables in your mind's eye, the table on the left is the one on top and the table on the right is the one on the bottom. So let's look at that real quick. Let me go ahead and just change up this and the whiteboard goes away. Okay, so one quick thing. They're talking to about three specific commands of this: union, intersect, and accept, okay? Union is a valid command in MySQL. Intersect is not. Accept is not. There's a question on the quiz that asks you, what are valid commands in MySQL? And three of them are union, intersect, and accept. And you would think from what I just said that the answer is just union and leave the rest blank. That is not correct. The correct is all three of them. So if you have not taken the quiz yet, can everyone hear me? Okay. So if you have not taken the quiz yet, if you get the question about which are valid operators, say all three of them, even though it's really only the one. We all know it's just the one, but the quiz makers thought it was all three of them. Okay. Okay, so let's look at some quick code here. Okay. So what a union does, okay, it just takes two queries and links them together in the results. That's all it does. It's a type of a join. It's a very caveman-like join. It's not very elegant. It's not very smart. It just runs two queries and then puts the results together. The thing about the results is the select queries have to be the same. Okay, so these have to look exactly the same or it will not work. Okay, so when everything else can be different. So I can do like where this, like if I run this one, it shows me where last names like are from the actor table and from the customer table. I can change this to, S, and it'll still work. Okay. It doesn't care about anything other than the select statement. That's why this is a real kind of caveman-y, non-eloquent way of doing a join. Okay. This example here, I wanted to show you really quick. Remember last week you talked about, when you do your inner joins, you want to do on you want to do them on a column that has a foreign key, so it makes sense, right? I did one. You don't have to. I just did one here. I did on last name, and there is no foreign key on last name, but it still works. I had customer last name and actor last name where the last names are the same. So it works. It doesn't have to be on a foreign keyed thing. It's just be on a column that it has in common. And the other thing is the columns don't even have to have the same name. It could be, as long as the data is the same inside the column, it can be joined on. Like if you had a table that said state as a column name and one that had ST as a column name, you could join on those. So I just want to show you right quick how the joins work here, okay? And then you guys can go on from there. So here I've got select A last name as actor, C last name as customer. From actor, left join customer on last name, order by last name. So because actor is on top, it's considered the left table. And customer is on the bottom, so it's considered the right table. So what will happen when I run this query is that everything that's in the actors table will show up in their column, and only the places where it matches will it show up in the customer column. If it doesn't have a match, it will show up as a null. So I'll show you what I mean here. So here everything matched up. So here I run this, and there is no Ackroyd in the customer table. There is no there's an Allen, but there is no Astaire. There is no Bacall. There's a Bailey. There's no Bale. There's no Ball. There's no Barry, whatever that's supposed to be. Barrymore. Okay. So this just drives home the point that when you run a left join or a right join, it returns everything from the table being called out and only the columns that match from the other table. So because actor's on top, everything, you will not see any nulls in actor at all. Everything will be there, okay? In customer, you see nulls everywhere. If I reverse it and do the right join like this, so I'm right joining customer to actor, customer is now the dominant table, and it's the exact opposite. Everything from customer gets returned, and only the things that match from actor get returned. Okay. In other systems, there is something called a full join. That doesn't exist in MySQL. A full join returns everything, whether it matches or not, and it's going to be, you'll see the combination of these two together. It'd be like if I did this. All right, I wonder if this will work. It didn't work. You can't union all. Oh, it's because the order by, I think. Yeah, that's got to go. Nope. Yep, I think that's got to go. I think if that goes, this will work. Nope, it did. So now so I've got left join, unioning a right join, and this is what you'd call a full join. Okay, so everything from the left is returned where it doesn't match on the right, and everything on the right is returned whether or not it matches on the left, and this is the entirety of a full join. So those are the three concepts we're talking about today: left joins, right joins, and full joins, even though full joins don't exist in MySQL. Does that all make sense to everybody? Does anyone have any questions on these things? You're join experts? I believe it. So start playing with them, and you'll see they actually become pretty useful. As we get the weeks on there, I'll show you guys some more complex queries how to deal with the nulls that are there. But right now, just the basic idea you need to get from this is how the left joins and the right joins work. Okay, and that full joins don't exist, and that intersect doesn't exist. Oh, by the way, did I mention? I did mention intersect and inner joins are the same thing. An intersect and interjoin. So if you run across a question on the quiz that's saying, could you write an intersect query as one query? The answer is yes. Because when you look at this union query, this is actually two queries. This is query number one, and this is query number two, and you're joining it with this union, right? So this is two queries. If I did intersect here, which won't work, but I can write it down. Oops, that was crazy. Intersect. There we are. Okay. Notice it doesn't turn blue. That means it's not a real query. So if I ran this and this were legal, it would return the same results as an inner join. But I could write this as one query, and it wouldn't have to be two like this. So if you see a question that says, can you write intersect as one query? The answer is yes, or true. How's everyone feeling on this stuff? All right. So then let's talk. Now, does anyone have any questions on anything up until week 5? Anything in the past 4 weeks? I'm glad. Anyone confused on things? Want some recoverage on things? No? All right, fair. Does anyone have any questions on the final project they're experimenting with? If their idea, where their idea is, how to flesh out their idea, any things on that?
I had a question. I guess
Sure.
I had like 3 ideas that I turned in on my paper, and so when do we know if our idea or which idea is accepted or what? I don't know. Like, do
Well,
I
okay,
just
so there's no question about it. You can do whatever idea you want. It's not me question. It's not a question of my setting. And I started. I don't know if you heard, but I'm behind on grading because of moving. So I'm trying to get caught up. So what were your 3 ideas?
it's my what I want to do is I want to, so I don't, because this is already done. So, but NASA, I wanted to do the just something on NASA's website.
Okay. Well, this doesn't have to be on a website. This can be something completely of your own creation, something that doesn't exist. You're not reverse engineering something that exists out there. So if you want to do something with space travel, then you can do something on your own space travel. It doesn't have to be something existing.
Okay. So, well, yeah. So it was basically like exploration, spacecraft, and missions and stuff. And then I looked to see, and basically NASA has it already.
Sure.
But yeah. And then my other one was like a personal home library database.
Okay.
And then like a nutrition or exercise tracking database.
All 3 of those would work, just wherever you want it, whatever you're gonna have more fun with.
Okay.
Any of those will work.
Okay.
So yeah.
I'll just see what you say about how to do it, and then maybe I'll just.
Well, we can talk about that real quick. So let's say you went with the space travel one, right?
Mm-hmm.
So let me. This one is not. I don't want that. Okay, so let's say you went with the space travel one, right? So no, let's do this here. Let's do this here. Go here so you guys can get. So if you go to File, New Model. You go here, File, New Model. That's 5. That's fine. Okay. Okay, we can go here and you can go to Add a Diagram. So in here, you can start building your ERD. And the cool thing is, when you're done building it here, you can go here and you can have it generate a script for it. So part of the ERD, part of the project is to develop in our ERD and then give me the script to develop to create everything. If you do it in here, you can reverse engineer it and it will write the script for you.
Okay, yeah, I remember doing that, I think in the last class.
Okay. So let's play with the NASA one because that's the most interesting one, right?
Yes.
So let's see what tables would we need if we're gonna if we're gonna do a database that tracks space travel. What would we need tables for? So we need spacecraft.
Mm-hmm.
Okay. So we need a spacecraft table. Okay. We would need a
I was seeing like a destination or like an observation,
destination. Sure. We'll call it mission.
Okay,
because it might be like your might be just orbit the planet or something like that, right? Okay. So we have a missions table. We'd have a table that would be launch location.
Mhm.
Okay. And then we'd have a table. No, stay here. No. No. Okay. Why are you being silly? You're embarrassing me. Okay. What is going on with this thing? Oh, that's why. Okay. I was using the hand here, so the hand does all sorts of things. Okay, so back to here. So we've got the location launch, and then we would need a astronauts table. Or whatever you'd call it. And then you would need a then we would need a table that would be which astronaut was on which mission. So let's see. Maybe I'll call this mission, not call this mission, we'll call this let's call this destination for right now because I'm not sure what we better call it. A destination. Okay. And then we'd have a missions table. Okay. Missions table. Okay, so we got that, right? So let's play with this a little bit. So that's 5 tables. So we're about 7 tables short. But let's just play with these 5 tables and see where we can go with it, okay? So spacecraft would have a spacecraft ID. And then it would have a name. And then it would have a capacity. And then it would have a class. Okay. So that's interesting that it's got a class. So over here, we now need a class table to see what kind of spaceship it was. Is it a shuttle? Is it a SpaceX rocket? Is it a thing? So like a new table here called class. Call this class. Okay. Okay, and then destination, we would have destination ID, and then we would have name here, and we'd have distance. Sure, that looks good. And then launch location, we would have a launch location ID. And then we have name. We would have an address. Over here under spacecraft, you would also have I have capacity there, good, yep, okay. And then you go away. Okay. So we have the launch location here, yep. Okay. And then we'd have astronauts. We'd have an astronaut ID. Right, cool, thank you. And then we'd have last name. Is your last name for now. Okay. Come here. Thank you. Then we'd have mission, and mission would have a mission ID. Okay, and then on that mission, we'd need to know what spacecraft was being used. And on that mission, we'd need to know what the destination was. And on that destination, we'd need to know where it was launching from. But with astronauts, we'd have to make another table here and call it mission astronauts. Am I going too fast? Is everyone kind of following how this kind of flows out?
It's making sense to me for sure, and I like how you're adding the tables as they are naturally coming. That's making
Well,
that.
this is how I always suggest building a database, because it makes sense if you just go and just going along. Oh, I need this, I need this. So here, mission astronauts here, and mission astronauts here. So that's a pretty good rough start on this. Okay, so let's follow this here. So we know we needed a spacecraft that was being used. ID, name, capacity, class. There's probably other things. Oh, we need to. I forgot this here. We need class ID here. Let's get this class ID, and then name. And then what we have to do is let's bring class over here, bring missions over here, bring you down here, get rid of that. Selected, and then, okay. So how did this come out? So I said to myself, I want to make a database that tracks space flight and space missions and space adventures. Well, obviously the first thing we need is spacecraft. Okay. So we need a name, how many people can fit into it, what the class is. I didn't realize there needed to be a class. I made a class table, whether it's like, in real world, like a shuttle or one of the 4 different SpaceX rockets, or one of the 4 different Blue Origins rockets, or one of the 4 different Virgin Atlantic rockets. So we need to know what class it is, right?
Mm-hmm.
Capacity might go under class. I'm not really sure, but we can put that wherever it belongs. Then we have a class, which is just name and the class of the rocket, whatever information will go underneath there. Then we need to know where it was going. We give it a destination. Destination have a name, destination have a distance. Might be other things involved in the destination. Launch locations, astronauts, and then we look here. So we need a table that tells us what the mission is, right? So the mission has an ID, but it will know what spacecraft we're using, where the destination is, what the launch location is, and also probably like here is like, original date.
Mm-hmm.
And then for anyone who has followed this, then actual date, because they're never the same. One of the benefits living where I live in Orlando is I see the launches.
Oh, that's one of my buckets.
To see the launch?
Yeah.
Actually, anywhere in the state of Florida, if you're on the East Coast, you can see a launch.
Really?
Yeah, because Florida is flat, like an ironing board. So if this shuttle goes up, and especially if they're at night, you can see them. I used to live down in Fort Lauderdale, and you can see them down in Miami. You can see them as far as Jacksonville. You can see the launches anywhere in Florida. Okay, so missions, date, and then here. So these are all one-to-one. There'll be one launch location per mission. There'll be one destination per mission. There'll be one spacecraft per mission, right? There'll be one class per spacecraft. But here, we're not going to have just one astronaut per mission. So I've got to have this table here that links the mission and the astronaut names, because this is one-to-many and this is one-to-many, which means these 2 tables together are many-to-many. Many astronauts will be on one mission. Many missions will have the same astronaut, right? So I can't just have astronaut 1, astronaut 2, astronaut 3 here. I need to have this here, okay? So there you go, you're about halfway. So does everyone see how that flowed? I know I went really fast and I apologize. We'll be doing a number of these over the course of the semester, so.
And how many tables did you say that we need to have?
Between 10 and 12.
Okay.
Between 10 and 12.
Okay. That is great. That gets me started, and
yeah.
Thank you so much.
And these tables need a bunch more columns. You're no way in Chef Word. The data is not complete in these columns, but it's basically a skeleton outline of that.
Yeah, there's so much more information.
And you got to make sure, again, make sure that the data types are right, because this would actually be a date.
Mm-hmm.
Look, that not decimal. What am I thinking? There we are. So make sure your data types are correct. But this is a really handy way of being able to create your ID, because once this is done and you save it, you can let's call this NASA. You can then take it and just reverse engineer it into the code, and it'll do the stuff. That's one good, because writing code to create tables is easy, but it's also mind-numbingly boring.
Okay. Yeah, I'll have to go back and look at my notes to how to do that. But
see, remember how to do it. It's been a while. See, new. Where is it? I'll have to remember how to do it, and I'll show you. If nothing else, I'll show you guys next week how to do it, because I have my brain. Ford engineer.
mm-hmm.
Is that what I want? Yep, that's what it is.
Okay.
Yeah. And there you go. Okay. So,
Awesome.
yep.
Great. Thank you so much.
Yeah. Well, I was going to do the races thing, but I ended up doing this thing instead. So, but it's the same general idea. You start with a table. You start with the main table you think of. You know, let's so I'm gonna go to new model here. New model. Okay. So let's play with, say we're doing like a runners for like to keep track of races. And I'll just do the table structure here, right? So the first table we need obviously is runners. So make a runners table. As a note, so here's a soapbox conversation. Many people feel that tables should always be singular and not plural. It should be the runner table, not the runners table. Because we're really only talking about one runner at any point in time in this table. Many people feel it should be the runners table with an S. I don't really care, as long as it's consistent throughout. But I bring this up because I find it interesting what people argue over in the workplace. And I've been in countless endless meetings discussing the naming of tables, and whether it should be plural or not. And then that's where I just pull out my phone and play solitaire, because I'm not getting involved in that conversation, because I don't care. Okay, so we got runner, so we need a races table. So we do a race table. Okay, and so we need a venue table, because the race has got to take place somewhere. Right. And then we would get rid of that text box. What other tables do you think we would need to keep track of a racing situation? We had a runner's table, a race table, and a venue table. Any thoughts?
You had like a place table, like where people place.
Oh, okay, that'd be good. Winners table or results table. Let's call that results. Good one. Okay, results. Okay, and then we would need a table that would say prizes, like what they won. Now, I will caveat this as I'm not sure that this is necessarily the right way to go with this, because things will change many times, but this is off the top of my head. And then let's see, race venue. I'm gonna change this to type, because is it a 5K? Is it a 10K? Is it a half marathon, a full marathon? Is it an Ironman? Is it a double Ironman? Is it a an Ant-Man? I don't know. Could be any kind of race. And then we need participants. We need to know who is in what race, because we couldn't connect that. So we have a race here. So we do race. So race here, and then we do race ID. Okay. And then let's give type an ID here. And type has an ID. And let's give venue an ID. Just so we can do some drawing, some lines here, right? Okay, then the race would have a venue ID and it would have a type ID. Okay, so we got that. So the race will be from the venue and the type of race. And then we'd have to do a participants table. And we'd spell it right. And then we give it its participants ID. Thank you. And then we go ahead and say, well, it's going to have a race and it's going to have runners. Okay. So we all follow in. Is this all kind of seeing how the flow goes? It's really, once you have a starting point, it becomes very easy to design the database. The problem actually becomes limiting it, because you can go off the reservation with these things. Particularly the columns and what data goes into there, So for runner, we want to know the runner's name, probably there. So here's a question. Which is better to ask for, the runner's age or the runner's birthday? And why? Fun fact, it's illegal to ask for a person's age on a job application, but it is not illegal to ask for their birthday. This states may vary, but if you know someone's birthday, you know their age. So why is knowing someone, so would you put someone's birthday in the runner's table or their age in the runner's table?
I would think your birthday, because they could sign up for a race, a year and a half ahead, and their age is going to change over time.
Exactly. And the word I'm looking for is dynamic. If you put a birthday in there, that's dynamic. I can figure out what your age is. So like it's 2022. I register with this company for races. I'm going to race for them for the next 10 years. When I log in, they're going to pull all my information from what's there. So rather than me having to update my age every year, it's just my birthday and say, hey, look, you're like, I was looking at my my company's HR website. I had to check something, and it actually has my age. It was like 51 years, 10 months. What is today? The second, 23 days. That's what they had my list, my age as. I'm like, that's really way too specific. No one needs to know that much about that, but that's what they had. But you're absolutely right, Jenny. We want the birthday because we want it dynamic. We want as much dynamic stuff as we can. Okay, we want to be able to have like figure stuff out without having to re-put data in there. Okay. And then I don't know how these results table will fit in. Then the prizes table, and this, like, you do a sponsors table. That'd be another thing, like who sponsored the race, and then when we look at this, it's like, I don't really want to get into test cases, but start wrapping your mind about like, what kind of test cases we come up with this data. If we pull that back up, my this model here, where'd you go? Where are you hiding from me? There's you. Let me open. Let me save that. Hang on a second. Cancel. Let me save this. Save model. And we're gonna call you runner. And let me open model. Open my NASA back up here. Yep. Oh no. Well, that's no fun. Why are you failing me? Oh, okay. Well, I'll figure that out later. That's a fun error. I hope you don't get that error. So when we look at our, if you remember what our NASA table looked like, when we start designing the data, we start designing these tables, we need to ask ourselves, what data can we pull out of this? Like we just like how many missions were there in May of 2025? We can pull that information out. How many which astronaut's been on the most missions, you know? So we want to start looking at that data too as we're creating these tables. Okay. Are there any questions on any of this? We've done 2 rough designs on databases tonight and gone over outer joins. How's everyone feeling on this stuff? Let's take a temperature test. Like, is everyone doing okay? Scale of 1 to 10. How are we doing with the course material so far? Everyone doing good? Anyone worse than a 5? Anyone worse than a 7? Everyone hover around the 8 or 9 mark?
I think I'm at a 5.
You're a 5? Okay.
Yeah.
So what aren't you getting that we can talk about?
It's not so much of just not getting it. It's just more of spending the more time to remember stuff and how things work and trying to change my mindset to think about things in a database kind of way.
Are you a developer?
No.
Okay.
Not professionally.
Okay. But are you studying like programming versus databasing?
I'm studying software engineering. Yeah.
Okay. Okay. So that's it. You bring in this point. There is a very different way that the database developers think than software developers think. So software developers, in my experience, are linear thinkers. How do we get from point A to point B and just code to that destination? Database developers are, I don't know if there's a word I'm looking for. They think around things. They find shortcuts to cheat, to find ways to move around. They don't want to do a straight line. They got to do the straight lines. And it's possibly because when you're dealing with data, you got tables everywhere, right? So you got to do that. But yeah, wrapping your mind around how the flow goes is an absolute thing. And it's not a question of necessarily fully understanding how things work. Or I mean, you've seen me so far in these 5 weeks. I have to look stuff up sometimes because I've forgotten it. So it's not necessarily knowing the answer. It's better to know where to find the answer than it is to know the answer sometimes, right? But yeah, I think if you start playing with the idea and I usually do this on paper. I don't normally do it on the screen here. I just figure when I draw the database out. But once you start playing with the idea on how the data works and flows and stuff moves across, it's really kind of cool. I used to like when I taught this in-person class, I have some schemas on databases that I designed. There were like 50 to 100 tables, and I would print it out and I would put it on the wall. I would get one of those poster printers and print it out, and it's just fun to look at. I'm gonna get off this soapbox because I can talk about how much fun databases are like all night, and I'm sure you guys have got way better things to do, and it's almost 10:30 my time. But yeah, so Joseph, just keep playing with it. Just keep, playing with it and write the queries, and just when you see the query, when you see the query in the exercises, try to write something slightly different. If the query says like find all the Harry Potter prequels and how they relate to each other, try to find another way to write that query with using different movies and stuff like that. But it's all about playing. That's why they call databases sandboxes, because it's all about playing. Yeah. Anyway. Any other questions, comments, concerns, thoughts? Speaking of space travel, did you see that they're going to crash the space station to the ocean in 2031?
I did not see that. That's bad.
Yep, they're like, well, it's already in a decaying orbit, so they got to get rid of it, or they can't control it. So they're going to do a controlled crash in 2031, probably into the Pacific Ocean, because it's the biggest piece of blue on the planet, and that should be fun.
Yeah.
Nothing could go wrong with that.
No, I will be watching that.
Oh yeah, I think we all will, because we're gonna make sure that it hits the right place, because it'd be bad if it didn't. I mean, there's big gaps in China where there's no one there, so they could probably aim for that. But I feel that would cause a big dust cloud and problems and a lot of angry Chinese people. Anything else? Any other thoughts? Because we can just go ahead and give you 15 minutes back to your nights because y'all are not in Florida, so it's not 10:30 by you guys or 10:15 by you guys. All right, well then we'll end it here. I'll post this tomorrow. Any questions you have, please keep in touch. Let me know what's going on. Where is who here is so show of hands, who's planning? I know Shonda, you're planning to do final projects. Aaron, Cade, Jenny, you guys doing final projects? Cool. Oh, good. Joseph, you can do a final project?
Yes.
Excellent. Excellent. Well, like I said, keep it as we go along the weeks. If you get stuck, you can share the screen, show us what you got. Well, I really like these to be community efforts. So I'm looking forward to next week and seeing some good ideas for some projects. All right, guys. Well, y'all take care. The Olympics start on Friday, so I'm sure we'll all be watching the Olympics together. Well, not together, but I like the Winter Olympics. I prefer the Summer Olympics, but the Winter Olympics are fun too. I like the luge because it looks like someone's just going to die doing that. That's just not safe.
Right.
All right, guys. Take
Okay,
care.
thank
I'll see you
you.
next week. Bye-bye.